are very excited to show some stuff, a lot of stuff actually that we've been working on for quite some time. Um, so the idea is that we're going to make this a two-part presentation. I'm going to start with like the basics, like the state of the union in terms of what is showing, what's been doing in computer vision and things like that, and then Dylan is going to take it from there, and he's going to go through Baseball CB, which is a collection of tools. It's a GitHub repo, but it's actually more than that. It's like a hub of. We want to make it like the hub for all things computer vision in baseball. So we're really, really excited to share that with you guys. And I'm going to start from here. I think the it's a little bit off the presentation. I'm gonna try to maximize it. Give me a chance. Hmm, I'm actually well. Uh, I don't see a way to make it bigger, but I'll take it from here. So what's the idea? The idea is that we talk about what's evolving on the world of computer vision in sports. How things have come from the early beginnings, and how what's the state right now, and what we're looking for in the future. Right. Um, Computer vision is just such a wide and major field, and you can find it applied in any kind of things. And but for sports, that's the thing that gets our attention. It has gone a long path, but mostly in other sports. Baseball, in terms of using it, it's quite not, I'm not gonna say it's new, but it's a recent stuff, because um, the early stages were applied to other sports like soccer, especially, and even cricket and all these other sports. So the idea of using computer vision is to analyze and get stuff, get more data from what's happening on the field beyond what the eye meets. It's been a while that we've been relying on our eye percent way of analyzing things, and computer vision has come a long way in giving us a better way of doing all that. Um, just a quick timeline. In the early 1960s, people and scientists used frame by frame analysis. It was just a very, coarse thing to do. Then in the 70s, first with the increasing of computer power and different styles of computer systems, and new systems emerge, and things like edge detection was the early stuff in that field. Then 80s and 90s brought us a bigger and people realized that there was a lot of things that we could get from there, and computers got more powerful. And it was when we started to see actual motion analysis, which is mostly what it's the interesting part in computer vision, object detection, tracking, and things like that, going from the static part of the image analysis to the video part. But of course, on that time, in that era, we didn't have still the power from the not even hardware or software power to create more specialized analysis. Moving forward to the 2000s and 2010s, it's when the actual revolution started in this field, especially with machine learning and deep learning coming and making a front row appearance, right? Things like decision trees, random forests, statistic modeling, CNNs, things that took a major leap starting with the 2000s. It's like it was like the new spring for machine learning, and which is and this is something that you will see a lot. It's the backbone of this AI revolution that we're looking at right now. That was the like the first steps that they took for that. So it all, of course, that impacted computer vision being a field of, or a derivated field of machine learning. What is what we need to know, like the basis for computer visions? And I'm sorry that it's still cropped. And I'm gonna try. You know what? I'm gonna try to share it in another way because I don't want. Oh my God! Give me 1 second. I'm gonna put it directly from the. Just a minute. I'm gonna try to share the other screen. Okay, just that looks better. I think so, right? Kind of. Okay, good. Okay, that gives me peace of mind. Okay, so the basic concepts that we need to know about computer vision. I mean, I'm oversimplifying the stuff here, but I just want to you guys to have an idea what's the, like the core stuff. It's that we have images representations that are usually talked about in pixels, but they are actually there are plenty of ways to represent the images in numeric ways. There is the feature detection, which is what we want to get from that image, like the edges, corners, textures, things like that. Then we have the image segmentation, which is like going a little farther beyond the edges and having things like what's inside a complete boundary. And then when we get that nailed down, we can do motion analysis and 3D reconstruction. No, as I said, I'm oversimplifying this stuff. Anyone that it's a little bit familiar with this knows that there is a lot of stuff going behind that. But I just wanted to show like the five core things that computer vision tries to acknowledge. When in the 90s and earlier, there were more analog based computer vision techniques like background subtraction, optical flow color based segmentation, and this was handled because of the limitations of them. When we moved on and we had the rise of machine learning, then we could get more creative and use more advanced techniques to analyze images like support vector machines, decision trees, random forest, and things like that. And this opened the door for what we are looking at today when we're applying convolutional neural networks, recurrent neural networks, and all kind of other techniques. Let's call them like that, that have allowed us to go through major breakthroughs. And I'm thinking of that. I wanted in this part to share like the major techniques or algorithms that are being used uh, these days in object detection and tracking. And I selected these four because we have been working in a lot of on them and to make them more accessible. And Dylan will give us a good hint of how does that apply in terms of specifically in baseball. But I lost the sharing just a sec. But the idea is to go through four different algorithms, which uh, just went off. Oh my God. Give me 1 second. I'll reshare it. Apologize. Being out of the house at such a short moment was it's killing me, but well, okay. I think this will work now. There you are. So the first algorithm wanted to talk about it's YOLO, right? It's not you only live once. It's actually you only look once, and it's been quite some time already that since it's been widespread used for object detection and tracking. It's more around 10 years, almost 10 years, which in computer years it's like I don't know 50. But it's actually a pretty good algorithm in terms of what it's capable of doing. As you can see here, um, it it can complete a lot of object detections and tracking tasks in a, let's say, simple way in terms of what it takes, of course. But it's actually a general algorithm. It can be used for a bunch of different tasks. It's used in industries. It's used in whatever you can you have object detections needs, you can do it. The impact in sports analysis, it's quite important in terms of how it can be easily adapted, but the pipeline to use it's still general. So you have to build your own tools and your own pipelines if you want to apply it for baseball. So there is not a specialized, or there was not a specialized um, package or pipeline to work with it. But it's actually a pretty cool and it should be like your starting point if you have moved from like the very basic things like OpenCV, which is like the standard introduction to computer vision in any application, right? So YOLO is like your logical next step if you want to get into computer vision. Um, if you move a little later or a little ahead of YOLO, then it's DETR, which I have in my poor English, I have not find a way to actually pronounce it. Never, so I will I will refer to it like that. And this is something that while YOLO was like independently developed, uh, and then it was taken by Ultralytics, which is this company that now provides like the easiest way to get into YOLO, but it actually comes with some situations in terms of licensing and things like that. The ETR, it's from what Facebook Meta actually, and this is um, another step in terms of doing object detection because it works with transformers, and we have found that this is actually a good replacement way of not working with YOLO because of the licensing problems, and that's why we also have introduced it into the tools that we have in Baseball CB. DETR has different. Let me go back there. Move. It works with end-to-end detection. It improves object relationships. It can work really well in complex scenes. And for baseball, it's actually really cool to have all these possibilities because, as you know, there's a lot of stuff going on in the baseball field once the ball is moving, right? Maybe it doesn't have the terms the movement terms like in other sports like soccer or basketball, but actually we have the situation where our main subject, which is the ball, is pretty small and doesn't you know doesn't have like too much in terms of what it takes in the screen. Its footprint is very small, so that takes you need to really really fine tune your models to make it work with that. Uh, there are multiple applications in which you can use DETR. And one, there's typically everywhere in the world you will find this kind of applications, and it works pretty well in terms of looking at objects that are, there are occlusions where the objects pass behind other objects and you need to keep tracking and things like that, and multiple objects in the same scene. It can be trained and fine-tuned to work very very well, and we have found that in our um, experiments with it, and our the things that we've been creating. Then we get into the visual, the BLMs, which are more advanced models because they're multimodal, and they can work in a different way in terms of they can analyze an image, give you context around that said image. One of those models is the Florence 2 models. This is something developed by Microsoft. It's a multimodal model in that you can work with the text, video, images, and you can do context recognition with them. And actually, it's very powerful, but it has some other complications. Of course, it's not the easiest thing to create a pipeline around. It's actually it can be very complex in terms of how do you create your training pipelines and evaluation pipelines and all the stuff that needs to be done to properly apply the model. So it's kind of good to have something to grab them around, and the same thing happens with other BLMs like Palygimmet 2, which is the other one that I want to share with you. Um, just to give you an example of how multimodal or this BLM works, if you see the video, you see that it not only recognizes the what's or tracks an object, in this case the cheetah and the truck behind it. It actually gives you context information around it. You can see that it says cheetah is sitting on a hill, a person looking through binoculars, a couple of people in a car. So you get a lot of information from the video beyond the simple object which it was trained to find. So this adds another layer to computer vision, another layer to what we can do around it. But of course, it brings other complications in terms of what I said, the training and all that stuff. Um, Same thing happens with Palygima, which is another state-of-the-art model in this segment. This one is created by Google. It has a bunch of great features like few shot learning. You can use limited data with it. You can use less data and for it to adapt and to work. It can work with multiple scenarios, and it can do generalizations better. Google says that it can do real time performance, but you will actually need really powerful uh, hardware to make that really happen. Even for training these kind of models, they are complex in terms of CPU power that they need to train and things like that. And we have found during our experimentation with them that they can take a lot of resources. But of course, they will bring a lot of new things to the table. These four examples of models used in computer vision, they can actually, and we have proven that they can be specialized to use in baseball. You can use it for player tracking and performance analysis. You can. I just put a bunch of things that can be done if you properly use computer vision to extract the data that you need. And of course, each one of them has its pros and its limitations, as anything in life. The thing is that you find out which is the best one suited for the application that you want to build. In that regard, what we wanted to do is to create a suite of tools that you can give the user the possibility to choose from, and they can use whatever it's better for them in their specific applications. There are other open source initiatives around it, but they are mostly on providing data or data sets and things like that. You can find drive lines up and biomechanics stuff, and they provide a lot of really awesome stuff. And it's very important to have all this information because it allows for people to do their own experimentations and create their own stuff. But there was a gap there in where we there were no real tools directly open source tools, because teams they create their own stuff. But for the rest of the people that doesn't have access to them, well, there was a need for them. Um, I'm gonna let Dylan talk about these actual tools and what can you find in Baseball CB. And well, I appreciate your time, so I'll let you take it from here, Dylan. Let me stop this. Okay.
Yeah, I can go ahead. Let me pull up my here, let me get this down. Let me pull this bad boy up. Okay. I should have shared. Okay, that's not coming up right. There we go. Okay. That's better. So I'm gonna introduce you guys a little bit to Baseball CV. Obviously, there was a lot of information there that Carlos gave you and a lot to digest. I tried to be active in the chat. Hopefully, I provided some links to the papers for some of the things that he brought up. Um, it's actually kind of funny they brought up Midsummer because I just watched that for the first time like 5 days ago and still kind of confused about the whole thing. Had to like look it up after the fact. It was a whole thing. I don't know. But I'm here to talk baseball CV. Our value, how we're trying to provide open source tools with baseball analysis and computer vision. Me and Carlos, we've dedicated a lot of time to this. This has kind of been like my side project as in school and like just trying to like actually provide these tools because I don't think there was an open source initiative with a a freely available license or a permissive license that was available. So we're kind of hoping that by providing these tools and kind of advancing this, that we can hopefully help people kind of get into this type of field. It's relatively newer. Obviously, there are still like papers being published every day that are important. There are models that come out the same way you see maybe a new LLM come out right every day. That's the same thing for computer vision models, right? There are new, better models continuously coming out for these specific tasks. VLMs specifically, which Carlos brought up, have been gaining a lot of notoriety for what they're able to do in terms of not having to fine tune it specifically and being able to one shot a problem. So being able to use the prior training in the models to actually understand current problems that it's never seen. So transfer learning, basically. So that's a little beyond the point, but I'm going to talk you through Baseball CV, kind of how to use the repo, what we have available, how you can kind of get into it, and whatnot. If you're not a programmer, that's fine. Hopefully, we're trying to provide some more tools going on to where people can actually just use these types of things without having to code at all. Right now, it's a lot of somewhat kind of needing the basics. But our whole goal has to make it kind of a high level language. So allowing people to just do simple commands to where they can generate really cool analysis, or take our primary tools and then conduct their own analysis. So that's by providing the data sets, providing the models, providing the classes to kind of go into that and talk through it. And for me too, I've kind of, had a lot of fun kind of just learning the fundamentals of some of this stuff, kind of going into it, learning about new models that maybe I wouldn't have looked into prior, that this has kind of brought me towards. So I think it's definitely been reciprocal in what we've been able to learn, but also, what we've been able to provide for the baseball analytics community in general. And I think an important note too, before I kind of go onto this repo, is we just launched baseballcv.com. So I mean, I can go into the chat maybe or something, but if you guys want to check about our documentation and what we're doing, you can go to baseballcv.com. Basically, we're writing out how we're using the repo, kind of providing some background theory to this, kind of a lot of what Carlos talked about, but kind of written out. So you can look at this, you can kind of get there, so combining, some of that complicated CV knowledge, but specifically towards baseball, so that people can actually, use it within their interests. Because I know that's kind of, if CV isn't what you're primarily interested in, but you're interested in doing something revolutionary in baseball, right? That would be how you would want to approach it in learning. That's still being built out right now. We just launched it a few days ago, but hopefully, by the time we can get that built out and provide more to the community. So I'll just walk you through our main README to begin, kind of talk through what we have, our assets, and whatnot. So our goal is to provide access to high-quality data sets and computer vision models for baseball. By sharing both our annotated data as well as our model weights, we hope to foster innovation in sports analytics, and right now specifically baseball analytics, so that developers can more easily analyze the game. So it is pip installable. So literally a simple command is all you need right now to be able to download BaseballCV, use our packages. We have further documentation on how to use that, and that'll kind of be walking through there. But, our goal has been really just making it as easy as possible for the user to be able to use our tools. So we've dedicated a lot of time to that. We've got a variety of data sets. Our baseball rubber home glove and our baseball rubber home both are preliminary data sets that Carlos designed basically to go into, analyzing key points in MLB StatCast feeds. So going through that and actually being able to identify where the glove is, where, the rubber is, where the baseball is, taking those so that analysis could be conducted. And then we have a simple one that's just baseball. So strictly tracking baseball. We have some available raw. So we have three actually different types of data sets. We have Cocoa data sets, we have raw photo data sets, and we have YOLO data sets. Cocoa and YOLO are both just formats for specific models. If you're using the YOLO one that Carlos mentioned previously, you're going to use that. A lot of the other models, though, Cocoa's pretty of a broad standard. And so kind of, a lot of models accept that for their input. And so we're talking through there, but, in case somebody just wants images and kind of wants to do their own project, we are providing raw photos. So basically that includes going to StatCast, and we actually have a scraper built in. Not sure, our goal has been to provide these data sets to where people can actually analyze it themselves, but they can also generate their own. We've pre-made some so that people are able to go through and annotate for their own projects. So that includes, whether maybe you want to identify or classify even a certain type of hit. Is a hitter lefty or righty? Something like that. Or, so you can go through and actually make your own annotations to feed into these models so that you can fine tune these, big models on those more downstream tasks. Downloading is pretty easily. We've got a pretty simple there. We've basically got an API set up so that, all you need is an alias for a lot of them. So you can just go through and literally load these tools just basically from saying something like baseball rubber home glove. If that's something that you wanted to get for the annotations. And so you can go through there, and then you can also do it from a text file. But, most of the time using our API is a lot easier. And then creating your own data sets includes actually we have one thing to where people can use our pre-trained models to actually develop some preliminary annotations. So that basically is kind of a semi-supervised way to where people can have their own data sets based on new photos, based on our prior models and what they've already learned. Um, it's still a work in progress, and there definitely needs to be some human oversight to that. But our goal for that was so that maybe we could take out some manual labor, because annotations, like, nobody likes annotating, right? Like, no, like, annotate, in case I haven't been clear, annotating is where you physically mark the points on the actual images to train the supervised model to actually learn. It sucks. Nobody will tell you otherwise. Nobody actively likes annotating. It's part of the job, though. And so we're going through, and it's very important to have like important annotations and accurate annotations so that we're properly learning and properly teaching the model. If there are bad annotations, the entire model goes to crap anyways. Pre-trained models, what we've got a good deal. A lot of our stuff right now is based on the Ultralytics YOLO library. We're kind of trying to get away from that. We don't love their permissions, and they've had some bug issues and some attacks. So we're trying to go away from that with Deter, which is kind of what Carlos was talking about, the detection transformer. And so we've already created our new class for that. But we've got our bat tracking model, our ball tracking model, our pitcher, hitter, catcher model, which I personally like. That's, for me, that's one of the most important ones for a lot of these biomechanical tasks that I've been, that people are talking about now, about potentially, generating, actual biomechanical data from single angle video, which is really important. Our glove tracking one, so literally glove, ball, home plate. And then we've upgraded our ball tracking model as well, in case you want our older or new one. We have, and then for our Florence models are incredibly hard to train. Not incredibly hard with the things we built out, but computationally difficult, in terms of they require a lot of resources because there are a lot of more parameters in the model. And so it takes a lot more compute power basically to go through, or GPU hours to be able to go through those. So we have a ball tracking model for both Polygemma and Florence that can kind of introduce you to that. And we have kind of in our further readmes, we've provided info on it, but that's still a work in progress. Right now, I think those detection models are probably for the better, using preliminarily. But yeah, it's really easy to download these things. Same type of logic that like we talked about before. Literally load tools, load model, and then using the path, or even just using our API. And we've got examples there that you can look into. I kind of want to show some examples. So this is an example output of our pitcher, hitter, catcher model. Basically identifying that pitcher. What it's doing is it's identifying the bounding box where that given pitcher is, as well as the probability of it being correct. So the model's not 100% sure. It's a range of predictions, right, is how these models work. So it's estimating the probability that that's a catcher, probability that's a hitter, pitcher, whatnot. And so from there, it's the same type of logic for here. So you play this, go like, oh, that's not going to run. Okay. You try to play that type of video. Oh, that one will run. But you kind of go through and, same, like throughout each frame, there's a probability. And sometimes there will be misses, as you could see maybe in the background, but sometimes they're not. And then we have some cool examples. This is one that that one's not going to play either. Oh, it will. Okay. Kind of. Technical difficulties, apologies. Basically what that's kind of measuring is, so it's taking the actual play as the glove moves throughout, and it's going through and it's literally tracking how the glove is moving. So you could see catcher movements or analyze how they're setting up for a given pitcher, or even try to derive some insight from that. And we have some current notebooks that are going through that we can walk through as well. In terms of time, I think I'm doing all right. Yeah. So I can walk through those preliminarily. Sorry if I'm going a little fast. Hopefully I'm just trying to there's a lot to cover with this. And so hopefully I'm trying to just give a wide preview of what's happening. Yeah. So for actually using the models, and I think this is where it's good, YOLO is built out. A lot of their tools are already simple and built out. It's pretty easy. You can either just actually initialize the model and then predict, or you can, basically like using their pre-trained ones. For the Florence 2 ones, we actually had to build out So you select the task, you select the image once you initialize the model, and then so one example is, so OD is object detection. So basically kind of doing the same thing as those YOLO models, right? Like extracting those bounding boxes, trying to get in there and figure it out. And then you have open vocabulary detection, to where you can actually do text input into there. So find the baseball, pitcher, and catcher, literally telling the model for Florence 2 what we need to find, and it'll extract where that is, and do an output. Then you have detailed captions. So that's kind of the nice thing about like VLMs, is so it can do multiple things at one time. Like it's not like just dedicated to one task. So you can also do detailed caption. You insert that baseball game.jpg, which is just an example one, and it'll generate a detailed caption for that given image. It's similar to how, maybe an LLM that you would see can generate text. It's can do a similar thing with images as input. Yeah, so that's kind of there, and that's how you would expect the results. Yes, same kind of logic for Florence 2, and we need to write down our PolyGemma stuff. We have a lot of notebooks. We're still updating those. There was some more from there on our main README. And so we're also trying to do some Streamlit applications as well. Kyle was actually the one who introduced me to Streamlit a lot and kind of got me on that train a little bit. And so for right now, we've got a test annotation app that's still a work in progress that we built out in case people want to work on that or build off that. Basically allows people to go through a data storage bucket and actually upload annotations directly to that. Hopefully, we're trying to add some in the future, basically using our models to where people can actually just interactively do it without coding. That's kind of our work in progress, how we're doing it. Still, there's definitely a lot of things that we're trying to get through, and so we're trying to be fair. But it's definitely a lot. We've kind of got a situation on contributing. Like, our whole goal is, me and Carlos, like, we're fine definitely with being the leaders, but our hope is that the community is willing to open up and try to actually contribute as well, to where they can kind of get into this, build their own projects, and help other tools, to where they're not only just showcasing their learning, but also, showcasing that they can create things themselves, but also, build off what we have. Our goal is to provide a stepping stone, which is kind of the entire point of open source. And hopefully too, I think a big consideration when we made this too is, as people get into CV, if we can provide these tools, maybe this can help people like actually land roles with teams, which is definitely a consideration. I know building this out has made me like just a better programmer in general, just in terms of we've actually already got, other than me, right? We've already got 2 contributors who already work for MLB teams. Pretty sure Joe Datoli, who used to work for Mizzou, he is, I think, working as a data scientist for the Cardinals. And then we have Jensen, who, weirdly enough, we went to the same middle school without any connection whatsoever. Figure it out after the fact, after he reached out to me. Small world. But bottom line, he is a machine learning engineer for the Cardinals. So we're hoping this can lead to some things, but, also kind of requires just contributing in general for that to happen. I'll kind of walk us through some of our notebooks. We've got more detailed readmes on each of our folders, kind of more thoroughly walking through what we have. Our inventory, like as you notice, this is more up to date than kind of our main one. Still working on getting all those other things. But yeah, we've got our ball inference, our glove tracking, our pitcher, hitter, catcher, and extraction. We've got our semi-supervised. We have our one knee down versus no knee down classifier that we use to basically take key points and then put that into a classifier object. I'm pretty sure it's an XG boost classifier, and then actually extract whether the knee was down or not. And then we have kind of an example notebook of Detter, PolyGemma, Florence, all those. A lot of those were more complicated that we kind of simplified to kind of within our classes to kind of build out. So I think a good example, let's just pull up the PolyGemma one here, is what we have. So basically, once this is all done mostly in collab, and Carlos has done an incredible job of building out a lot of these. And so basically what we've been doing is going through and kind of just, providing those basic tools for how to do it. a lot of our VLM models in Even Debtor are based on Hugging Face. If you're not familiar with Hugging Face, it's an incredible tool. Basically, a lot of the open source initiatives in large language models, VLMs, computer vision, any type of like deep learning is a lot of it is based in Hugging Face, to where people can store models for relatively free if you're not a large organization, and can share them publicly so that other people can use it and do other tools. And so it's another open source initiative with that stuff. And so we use that implementation for how we're downloading a lot of our models from there, so that people can freely use them and build off what we have with their pre-built tools, which are very built out and very thorough and very, frankly, easy to use. So basically, after initializing the model, just taking PolyGemma, this is an example, load a data set. So that's just an example of what we have, the baseball data set. Once we have that, then we can define the class that we're looking for. In this case, we just want to train on baseball. We want the model to just learn where baseball is. And then from there, we can fine tune the model. It's literally simple. It's just model.finetune. All you have to do, you put it in that, and the model's going to fine tune for you, train. You just put where the data set is. So link to the folder, the classes, so the classes that we predefined, the train test split that we have in there. So for us, that's 80 training, 80 vow, and then 80 test, or 10 vow, 10 test, and then epics. So the amount of, step iterations that you wanted to go through each batch, of that are actually in the images. And then we have other things. These types of VLMs are trained on this more efficient tuning called LoRa, and so these parameters relate to that. I won't really get into that because that's a whole nother topic, but bottom line, we have a use case, and we've got, if you dig deeper into these models, I would highly recommend trying to understand the fundamentals of what's actually going on. So that's kind of what we've been doing there. That's kind of just an example. And then so for there, this one, I'm pretty sure this is the intended target one, was very cool. I don't think they have the image outputs, unfortunately, in there. Okay. But basically we use the pitcher, hitter, catcher model, and then some basic pose detection to detect, what people are actually doing within these things. So hopefully, basically getting the slope of the line, the endpoints, the distance between the points. There's a lot of stuff you can do. Our kind of goal with BaseballCV in general is to provide those basic tools to where people are able to generate their own functions like this, to where they're able to do these types of tools. And Carlos is too, and I'm actively, kind of less actively, but kind of trying to provide the baseline for that, so that Carlos and them can work on kind of going towards these points in an actual real space, but also showing actual applications. Like, can these models actually be used, right? Like in an actual setting. So this is an example. So we have the estimated plate target based on this, based on all these functions. And so, in theory, based on the glove movement of how it was going through there, as well as the catcher location, we can gauge an estimated target. And so for there, I'm pretty sure I can. Okay, it's not letting me zoom. But yeah, there we go. That's perfect. So basically, we've got more of an estimated plate target here. And so you can kind of go into how that's, estimated through these functions. I would highly recommend going through it more thoroughly. And then, we can basically using the same thing of just, body movement, whatever. This is using MediaPipe, trying to implement MediaPipe and more. Still a work in progress, but that's kind of a good example of some stuff we've done. It's, there's a lot. And so I think the big thing is spending time going on the actual repo, trying to figure it out. And then, eventually we've been trying to be more thorough with our documentation, which is kind of, me pivoting a little bit to BaseballCV. Basically our documentation's hoping to get into all of that more. So we've got some introductions, what people are actually able to do, ball trajectory analysis, catcher intent location, kind of what we've already talked about, going through that and, just kind of writing it down so that people can understand. And then we have some background theory. So, kind of what Carlos talked about a little bit, And then, hopefully our wide theory is that, we really want to grow. And to do that, we need people to understand how baseball CV works in general, how we're growing, how we're trying to do things. This is our project page. So basically, we have an estimation of all of our things that we're trying to get through. There's a lot. So basically, that's all of our done ones, but we have some backlog for things that we want to do. We have some things that we're ready to do, and we have some things that we're actively doing. For me, that's basically cleaning up our whole code base and redesignating it over the next week. And then for Carlos, a lot of that's our documentation. We're trying to go through and thoroughly make this a thing to where, regardless of where we go, this is a sustainable project that people can keep growing on. So kind of going through there, not a lot of, not a lot more else that I can kind of get into without getting into the weeds a little bit. We do have our own Discord, and I'm pretty sure we could probably provide a link to that. But our goal, make computer vision more accessible for everybody in terms of a baseball context, and I think we're trying to get through that and do that, especially for Python developers or people who know the preliminary coding. But ideally, that be for everyone, to where everybody can learn about that. And so we're starting. And so we hope this presentation has been somewhat informative for how we're doing that and going about that. If not, I guess you just heard me rambling for, the last 20 or so minutes. But hopefully there's been something valuable that's come from this. And, we've put a lot of time and effort to it, and we're really, really excited to see where it goes.
It's been really, really good, Dylan. Thank you. I just wanted to add to all that what Dylan said is that the idea is that to make it as accessible as possible for everyone, so you can join us and help us build this out, as he said. um, you can be this 21 years old code wizard as Dylan, and or 3 times older dude like me that into it. I mean, there is the possibility for everyone to help, and we are open to hear from you guys, and we just want to grow it and make it as accessible as possible for everyone. um, I don't know. I can show like one of the examples that didn't run for you, which is the glove tracking with which I find so cool. I- if you may just let me show it for a minute. Give me a sec. Does it show? No, it's not showing, right? Does it show? No, it does.
It did, but I'm not sure where it went. I think we're running somewhat. Okay, there it goes.
There it goes. Okay, so this one was written by Dylan, and it's pretty cool because you can see how you relate the coordinates from what the model is detecting to a XY plane, and you can from there. I think Joe did a lot of use this as his base for the intent one, right?
Yep. Yeah, absolutely. Yeah, that was kind of the preliminary stuff. It's really cool. There's a lot of cool stuff, but literally being able to track that, and then we're able to perform a perspective transform based on the coordinates of the pitcher, the hitter, and the catcher to be able to actually generate on a flat surface where the catcher is. It's quite incredible.